Hello. When I was at school, my least favourite subject was maths. I didn't like maths because, well, I wasn't very good at it, and it was only when I was grown up that I discovered I have dyscalculia, which means I have a problem with numbers. It's a bit like dyslexia, which is a problem with letters and words. Now, one of my favourite lessons was art. Not because I'm very good at art, but because I had a lovely art teacher. Well, today I'm not going to tell you a Bible story. I'm going to show you something really interesting that brings both maths and art together. So if I take my red paintbrush, I can paint something special with yellow letters that will tell you what we're going to be looking at. There we go, it's Fibonacci. Now, Leonardo Fibonacci was an Italian gentleman who discovered a pattern or a sequence of numbers which is now called the Fibonacci Sequence. And the sequence is this. I'll draw them all in here. So we've got 0, 1, 1, 3, 5, 5, 8, 13, 21, 8, 13, 21, 34, and 55. It should also have a 2 in there as well. So you get this sequence by actually adding together the two preceding numbers to get the next number. So 0 and 1 obviously comes to 1. 1 and 1 equals 2. 2 and 3 equals 5. 3 and 5 equals 8. 5 and 8 equals 13. 8 and 13, etc., etc., until you get all the way down to 55. Now, Fibonacci was trying to work out how many rabbits you would get at the end of a year if you started with just one pair of rabbits. Now, at the end of the first month, the 2 rabbits, they mate, but they're still just one pair. At the end of the second month, they produce a new pair, so now there are 4 pairs. 2 pairs. At the end of the third month, the original pair produce a second pair. The second pair, they mate, but there are now 3 pairs all in all. At the end of the fourth month, the original pair has produced yet another new pair, and the pair born 2 months ago also produces their first pair, making 5 pairs. And so on and so forth until you get all the way through, until you get, well, at the end of a year, you end up with a lot of rabbits. Well, whilst Fibonacci was working on this sequence, other mathematicians discovered something amazing. They discovered that the numbers in the Fibonacci sequence keep popping up elsewhere in nature. And we can actually draw out that sequence. And we can draw it as a series of squares. It's also sometimes called the golden ratio. So let's have a look, and we'll draw out our first square and look at the sequence. There we go, that's our first square, and looking back in this sequence, 1 and 0 and 1 make 1, so we get another one just there. And then when we start here, we've got 1 and 1, that makes 2. So what we do is we now draw another square, but it's the same size as the longest one on the previous one, which is hard to explain. So this bit here, we draw a square alongside there, like that. And then we draw another square where the longest side of this lot is equal to the sides on this one. Whoops, that wasn't very good. And we keep doing that, so we can then go from this square, one that is the same sort of length as that, as for the 2 sides, so we go over to there. And we do that again going down this way. And of course we do the same thing again, and we'll go over here. Another square, that's that using that ratio there comes all the way up to there. And then my final square uses that long side as its sum, which comes right over to there. Okay, we'll stop it there. We could keep going on, but I'd run out of paper. What I'm going to do is I'm going to take a different coloured pen now and draw a spiral through each of the squares like this. We start, where do we start? There. There we go. So we've gone through a spiral through each of the corners, going through, and we end up with a spiral that looks like a seashell. Isn't that amazing? Now, here's a photo of a shell that is exactly the same ratio as the spiral one that I've drawn. Now there's lots and lots of other places within nature that we can see this Fibonacci sequence. Well, have a look just at a few of them. So pine cones, these also have Fibonacci spirals. And when you next see a pine cone, turn it or pick it up, turn it upside down, have a look at it, and you'll see that the seeds on the bottom are arranged in that spiral. Mine here, when you count them up, is arranged in a series of 5s and 8s. Most flowers have their petals arranged on the Fibonacci sequence. So if you go out in the garden and have a look, see if you can find some flowers that either have 5 or 8 or 13 or 21 petals. Sunflower seeds are also arranged in the Fibonacci sequence. Their spirals are really complicated and they sort of go in opposite directions. And it seems that the way that nature can pack the most seeds into a smallest space is by using this golden rule or the sequence. So why not grow yourself some sunflowers, wait till they're fully grown and have a look at the spirals that you get there. The Romanian cauliflower or Romanesco broccoli is a brilliant example. Just take a look at this photo. And there's more places you can see this sequence. Have a look at the weather when you've got the weather maps on the television. This one here is a view of a hurricane taken from a satellite. This next one is a spiral galaxy taken in space. And there are loads of other places you can see this golden ratio or the Fibonacci sequence in nature. My last one is the human DNA, the genetic code. Now DNA has a double-stranded helix with 2 grooves in its spirals. These spirals have a ratio of 21 and 13 angstroms. But first, let's look at some more maths. Let's work through the numbers again, but this time we're going to divide each number by the one before it in the sequence. To speed it up, I'm just going to start at 5. So 5 divided by 3, we're looking here, working our back, equals 1.66. We go on to the next one, 8 divided by 5 equals 1.6. If we take the next one in the sequence, 13 divided by 8 equals 1.625. And if you carry that on and average all the numbers out, you get the number 1.61803. And that number is the same value as our DNA. So why am I telling you all this instead of telling you a Bible story like I normally do? Well, lots of people think that you can't believe in science and believe in God. Some even think that science proves that there is no God. But actually, lots of scientists either believe that there is a God who created the world or that there is an intelligent design behind the world. Of course, the Fibonacci sequence doesn't prove that there is a God. But it does make you wonder, can the world really be just one big accident when you've got something like this that runs all the way through it?